In this section, we're going to talk about inverse functions. The notation for an inverse function is f of -1 of x. That denotes that you're finding the inverse of f. So you say f inverse of x. Now the -1, you might have seen it before, where it means to take the reciprocal. In this notation, so in this instance, if you see it with f to the -1 of x, that does not mean to take the reciprocal, so not the same as the reciprocal. So what does it mean? So if I say find the inverse of f, what you're going to do is if you have f of a equals b, then what the inverse does is switch your domain and range. So where I had a, that becomes b, and that equals a now when you do the inverse. So this is basically you're switching all your x and y values, or switching the domain and range. That's what you're doing when you're finding the inverse, or that is what the inverse is of a function. It's another function where the domain is now the range and the range is now the domain. So if I give it to you as f of 2 equals 4, then that means f inverse of 4 equals 2. So with inverses, we can do a lot of things with the graphs and with the equations. Let's look at the graphs first. The graphs of inverses, since you're switching the x's and the y's, what that shows on the graph is a reflection across the line y equals x. So your linear parent function, that you're going to reflect across that line. So that's the one that goes through the origin and has a slope of 1. That's the line y equals x. So let's look at x squared. If you look at x squared on the graph, that's your parabola. I'm going to plot a few points here just so you can see how wide it is. That's f of x equals x squared. If I reflect it across the y equals x line, that's going to give you a graph that looks like this. Picture folding along that line. It's going to flip that over that line to look like that. So that would be, if this is f of x, this graph would be f of -1 of x, or f inverse of x. Now the problem here is that when I do that, the inverse isn't a function anymore. So what that tells us is that only one-to-one functions have inverses. And remember our definition of one-to-one, it has to pass the horizontal line test. So if we look at our original function again, it doesn't pass the horizontal line test. So when you reflect it across there, it's not going to pass the vertical line test to be a function. So what that means is if we leave it like this, x squared does not have an inverse. Because it's not one-to-one. Now there is a little trick or a little fix to this, and that is instead of using the whole parabola, if we restrict it down to half of it, and it doesn't matter which half, I could use that right half or the left half. If I just look at that and reflect it, it's going to just reflect over half of it. And then you will have an inverse function that you can flip across the line y equals x, and it's still a function. So our fix or our trick is to restrict the domain of our original f of x to make it one-to-one. So what it'll say is f of x where x is greater than or equal to 0. So it'll restrict it to this domain. So we just have that half. And then you can have a reciprocal, or I mean an inverse function. Now that's graphically. Let's talk about finding inverse functions algebraically. I'm going to write down the steps here, and you're going to follow these steps each time, and then we'll do a couple examples. So the first thing you're going to do is replace f of x with y. So I'm going to rewrite f of x with y, and that's because f of x is equal to y. And then we're going to switch x's and y's. Just like the definition of an inverse, you're going to switch the domain and range by actually physically switching the x's and the y's. The third step is going to be solve for y. The fourth step is replace y with f inverse of x. So you're turning it back once you've solved for y using function notation as f inverse of x. And then 5 is just a sometimes, if you need to, restrict the domain. So you won't always have to do that, but you'll restrict the domain when needed. So following those steps each time, let's look at an example. If I want to find the inverse of f of x equals 2 over x minus 3 plus 4, I'm going to start with, first step is replace f of x with y. And then I'm going to physically change all my y's to x's and all my x's to y. So that's going to be x equals 2 over y minus 3 plus 4. So I'm switching the domain and range. Now the third step is solve for y. So algebraically, I'm going to subtract 4 from both sides. So my goal here is to get y by itself. So that'll give me x minus 4 equals 2 over y minus 3. My 4's will cancel. I need to get that y minus 3 off the bottom. So I'm going to multiply both sides by y minus 3. and that will cancel with the denominator on the one side, and that'll give me y minus 3 times x minus 4 equals 2. And then, again, my goal is to get y by itself, so I'm going to divide by x minus 4. So algebraically, I've showed you the steps, but basically what you've done is, by algebra, switched the x minus 4 and the y minus 3. Let's go up here so I have more room. So what I have is y minus 3 equals 2 over x minus 4. Almost done. Y needs to be by itself, so I'm going to add 3 to both sides. So I've got y equals 2 over x minus 4 plus 3. So the inverse function, now we're ready for the fourth step, is f inverse of x. I'm just replacing y with that. It's equal to 2 over x minus 4 plus 3. And that is 1-to-1, so we don't have to restrict anything. Let's look at another example. Same thing, same steps. I'm going to change my f of x to y. So that's the first step. Second step is switch the y's and your x's, so this becomes x equals 5 minus y over 3y plus 2. Now I need to solve for y, so I'm going to start by getting this y out of the denominator. So that's going to be 3y plus 2 times x equals 5 minus y. Now, you notice I've got a y on each side. I need to collect those on the same side. So before I can get this y by itself, I need to distribute that x to get rid of the parentheses. So I've got 3xy plus 2x equals 5 minus y. So now I'm going to collect all my y's on one side. So I'm going to add this to both sides to get it over there, and I'm going to subtract this from both sides to get it over there. So I'm going to end up with 3xy plus y equals negative 2, let's leave the 5 first, 5 minus 2x. So I've added y to both sides and subtracted 2x from both sides. Now notice I've got all my y's on one side. Both of these have a y, so I can pull that y out or factor the y out of that, which will leave me 3x plus 1 equals 5 minus 2x. And then let me bring that up here. To get y by itself, I'm going to divide by 3x plus 1. And that leaves me y equals 5 minus 2x over 3x plus 1. So that one got a little messy, but if you just go through step by step, you want to isolate your y's and get y by itself and then solve for y. So here I had to do a little finagling to get y's together on the same side right here, and then I can pull a y out and then get it isolated. Here we've got another example. It says find the inverse of f of x equals the square root of x plus 4. Remember, the square root of x plus 4 is the square root of x shifted to the left 4. So it looks like that half parabola right there. So same steps as before. I've got y equals the square root of x plus 4. I'm going to switch my x's and y's. And then I want to solve for y. So I need to get rid of the square root. So I'm going to square both sides. So I've got x squared equals y plus 4. Because when you square the square root, it gets rid of both. Then I'm going to subtract 4 from both sides. So I end up with x squared minus 4 equals my y. So I think I forgot in the last example, but that's my f inverse equals x squared minus 4. Now this is where you have to be careful. X squared minus 4 is the quadratic move down 4 units. So if you think about this, if I shifted the original function, the one in blue, over the line y equals x, that's just going to give me this half. So this is an instant where we're going to have to restrict the domain, because this part is not in the reflection. So the fifth step is restrict the domain if necessary. So we're going to say this is our inverse where x is greater than or equal to 0. And that'll give us just that right half of the parabola instead of the whole thing.